Hello and welcome to our first webinar in a session of tutorial webinars all around busbar protection. And today you will get some insights on the SIPROTEC 7SS85. And you will see if busbar protection is something for you and if you can handle it. By the way, I am Michaela Mönikes. Some of you might know me from being a tour guide on the Siemens booth or being your moderator in our electrification and automation webinars. And that's why I will guide you today through this webinar. And to warm you up a bit and to get some insights kind of on your knowledge, we start with the first survey. You will soon see a QR code displayed on the screen, and you can either scan this code with your mobile device and then take part in the survey, or copy the link to the survey from the chat. There you are. So once again, just scan it with your mobile, or click or copy and paste. I think it's from the chat. I think Gerhard in the background, put it there. You can also copy the link into your browser. So just as you like it. And while we hope for a lot of answers for you, it's my time to present my first experts to you. I am very happy that my dear colleague Nina Höhn is here with me in the studio. She's an experienced technical support engineer for SIPROTEC devices. Oh, and I'll still let you scan this over there. Let's see, there you go. And Nina is a passionate promoter for differential protection. And let's see here in the studio if we already have some results from the survey. If you out there are already awake and take part, and tell us a bit about what you associate with busbar protection. Oh, thank you so much. There's already something in. Oh, you think it's cost intensive? Yeah, could be. We'll see something around that. Needs to be fast tripping. And let's see. Oh, more is coming in there. Thanks a lot for participating. I see a lot of information there. High short circuit currents. Yeah, that's true. We talk about busbars and not just one single cable. Siemens associated with it. And now it's almost a bit too small for me to read, but I see fast. That's true. It needs to be fast. Good. I hope that we deliver something good there. Reliable. That's for sure. And yeah, sometimes it might be expensive. We'll see. But I mean, we need to protect the assets and it needs to work really reliable. So sometimes it's, yeah, you can spend less money, but if the protection doesn't work, then might become a problem. So thanks for participating in the first survey. So what you associated with busbar protection, and we'll see how that applies or fits to what we are going to tell you today. And then we take the next question. How do you estimate your personal protection know-how so far? Once again, either scan the barcode with your mobile or copy the link from the chat and take part in the second survey. And this gives me once again time to present our next expert, because together with us here in the studio is also my dear colleague Rainer Goblirsch. And Rainer is definitely a specialist for low impedance busbar protection. He's a member of different IEC groups for differential busbar requirements. And he's a member of the SIGRE working group that takes care of process bus around busbar protection. So you see, he's an expert here. And let's see, how do you estimate your busbar protection know-how so far? Do we already have some results? Oh, perfect. That looks quite good. There's a lot of basic know-how around. No idea up to now. That could be true for me, so it's also some in there, and that's fairly okay, because that's why we do this tutorial right here for you. Some even have advanced knowledge, and we have some experts out there. So I hope that still you will get to learn something more. And I'd say the average is basic, and that fits perfectly to you out there. So I told you in the beginning, I will be your moderator for today. And so let's start with a short glimpse into the agenda. We are already in the welcome and opening part of it, and then we will continue with Rainer presenting the busbar protection and its important role in the power grid. After that, we'll see Nina on stage talking about or presenting options and differences of different busbar protection solutions. And then you see this Q&A means we'll have time for questions and answers. Then I think we all need a short bio break and give our brains a bit rest and our eyes. And then we'll meet again. We'll keep the channel open, but we'll really meet again and continue the journey afterwards again with Rainer, talking on selecting the right devices according to your primary equipment. There it's more around the basics and the theory. Another break after his questions, and because that's a long block, then we have at the end Nina again on stage talking or presenting the online device selection tool for different busbar protection configurations. And at the end, once again, a wrap-up session to answer as many of your questions as possible. And talking about questions there, that brings me to what we want to do it. We want to have it as interactive as possible. So whenever you have a question to our expert, go ahead, type your question into the questions field. And then at the end of each session, I will be your voice and read your question to the experts here. You can use the chat and put some information there, but be informed, I will read questions from the questions field. So, and thanks for already participating in the chat and in the survey so far. But I think now we are curious to learn more about SIPROTEC 7SS85. I hope that you are as curious as I am. So we need Rainer back on stage, and he will tell you and start something about busbar protection. Rainer, let's go.
Thank you, Michaela, for the introduction. Okay, let me learn about to handle the slides. Okay, the agenda. Michaela has already explained about the agenda. So just what will explain I now, busbar protection and its important role in the power grid. So that's a little bit a warming up, both for me and also for you, about really the necessity of protection and busbar protection in especially, and also a little bit I will explain also some very basics of the basic definitions of busbar protection. Task of protection. The protection cannot prevent the short circuit. I guess you know it. Let's see this small video. What we have seen here is a so-called involving fault. So it started from busbar protection point of view as an external fault. We have seen a very strong arcing, and the busbar were on the top of this small video. And as soon as this external arcing has reached the busbar protection has immediately cleared the fault. So busbar protection cannot prevent the short circuit, but it can minimize the results of short circuits by protecting the equipment from overload and also from damage. Of course, very important to save human life. And how does it do? Protection protects human life and prevents damage from the equipment by tripping really selectively within milliseconds to maintain also the network stability. That was for protection in general. Why do we need busbar protection? A busbar is really a point of convergence of many circuits. It's a concentration of power, and therefore really high and destructive fault currents can result. So you can see this in this very small single line diagram. Single busbar, we have several generators, we have several consumers like motors here in this case, and we have also transformers to a lower busbar voltage level. And so really here the busbar is a very high point of convergence, a high concentration of power. And therefore, that's the reason a busbar fault really endangers the stability of the whole grid. If a busbar fault could really not clear it in time very quickly, it could happen that really a whole station, the net will be unstable really for a whole country, for a whole continent like Europe, if we have a high destructive fault on a busbar which will be not cleared on time. So the general requirement to clear a busbar fault is 200 to 100 milliseconds, inclusive the circuit breaker operation. This sounds quite high, so that's a general requirement from the government, but typically for really high voltage, extremely high voltage busbar protection, the requirement from the utilities is that the device itself, without the delay time of the circuit breaker, is to clear the fault really sub-cycle. That means to really detect the fault within one sub-cycle and at least to activate the binary outputs of the device itself. Also, we need a high degree of availability and dependability. And especially in very extreme high voltage level, in the meantime, we have also more and more redundant busbar protection. That means a main 1 and a main 2 busbar protection system. And a busbar fault also, because it's very destructive, can lead to very, very serious damages of the switchgears and may also endanger human life. And therefore, once again, really a very fast and selective fault clearance by busbar protection is necessary. So, before we'll come to the next slide, I have also prepared one question. Will be interesting. What will be the outcome? What do you think is the average probability of a busbar fault? So once again, scan the barcode or copy the link and give the answer. Will be interesting. What's your opinion about the average probability of a busbar fault? Oh, okay. First, please the slides. I will wait. I have prepared the slides first, so give the audience a little bit time to answer. Reasons and probability of a busbar fault. What are the typical preventive measures? Typical preventive measures are single-pole metal enclosed switchgears, so-called GIS stations. And also with GIS stations, we have a division into separate compartments. This reduces a lot the probability of a short circuit in our busbar protection. And of course, state of the art, you typically have also a switchgear interlocking available in each substation. What are the reasons? The reasons are mainly mechanical problems, especially problems during the running time of the disconnectors, mechanical problems sometimes of the CDs, but mainly of the disconnectors, sometimes also mechanical problems of the circuit breaker. Not so much a problem in GIS stations, it's more a problem in air-isolated substations, is to have isolation problems. pollution flashovers. We have seen this in our short video at the beginning. This was most likely an isolation problem. And I would say that's really the most likable reason for busbar protection faults are human errors. So typically the switch on default errors. So maintenance activity, the cable or the busbar has been earthed by some cable. The maintenance activity should be removed. It was finished, and somebody forgot really to remove the earthing cable and once again. And then we have a typically switch on default situation, which is in the basic and human error. Okay, now maybe before I will give you the answer of your question. What is the average probability of a busbar fault? Now, Kat, can please. And now I have a little bit problems. So 50% one each year, 80% two each year, 43% have the opinion that every 10 years we have a busbar fault, and 24 thinking about one every 20 years. Okay, that's fine. So the majority of the audience have given the right answer. Can we switch again? So the average probability, of course, it's only a very rough average, is so typically one fault per 10 years to have a busbar fault. But if we have such a busbar fault, really the impacts can be really tremendous. We will see it later. And also maybe one additional remark, we have only one fault every 10 years for a busbar fault. But my former colleague, Matthias Schick, maybe some of you still know him, he said every time, but we have the highest probability of a fault per meter. So if you're thinking, okay, the busbars compared to really overheat lines for more than 100 kilometers, okay, the probability is higher, but the probability per meter, you have the highest in the busbar. Shortly before this warm-up, I will show you a very impressive video. I have taken this video by myself during some protection tests in an air-isolated switchgear in Austria. This air-isolated switchgear in Austria is now removed via a new GIS substation. And so this GIS substation will replace this air-isolated substation. And so this air-isolated substation, it was possible to make very high destructive tests with this air-isolated substation because it will be replaced now by this new GIS substation. And what we see now is what happens if we have no dedicated busbar protection and we have only a backup protection, and in this case it was a distance protection in the reverse zone with a clearing time of 300 milliseconds only. In former times they had protected the busbar with the 7SS52, and I personally could block the 7SS52 so that we have the fault clearance time of about 300 milliseconds only. And let's see what happens if we have a high destructive busbar fault and a busbar protection without dedicated busbar protection. Okay, you could see it was like an atomic bomb. So you couldn't see anything for some seconds because your eyes they were completely flashed. And afterwards, you could see on the substation, on the cable, where this short circuit has been simulated and has been tested, it was completely carbonized. So this is really a very impressive video, which shows really how necessary really a dedicated busbar protection is, and it's really in the high voltage really to make only a busbar protection with a backup protection of 300 milliseconds of the distance protection. It's really not state of the art. come and let us explain a little bit really some fundamentals, some fundamental definitions. We need in busbar protection really a selective tripping, and really a selective tripping is really a basic demand of each multi-section busbar protection. This will come more in detail later. Just to repeat the most important definitions as much as possible. So selectivity in a busbar protection scheme is achieved by splitting the protection, the whole busbar, into independent zones. We call it measurement systems or measuring systems. And as it is a differential protection, the limits of the measuring systems are, as in every differential protection systems, are the current transformer. So really the area will be limited by the current transformer. And the disconnectors, we need disconnector positions in switchable busbars. It's different, of course, in a single busbar, but in a double busbar, triple busbar, we need really the disconnector image to assign the feeder currents to proper measurement systems. What elements do we need to configure busbar protection systems? We see here now a little bit more complicated busbar protection system. We are seeing here a triple busbar with also a transfer bus system and one coupler. So what do we need to configure a busbar protection system? We need to configure the busbars, shown here. So we see here all in all 6 busbars, 6 independent measurement systems, busbar sections. We need the busbar disconnectors. We need the busbar disconnectors here. You can see here also the busbar disconnectors. We need to configure the current transformers, also seen also with these red circles. And we need the circuit breakers. And if available, we have to configure also the sectionalizing disconnectors. And if available, also we have to configure the transfer bus disconnectors. Whereas optional only are the line disconnectors. So line disconnectors we need only in case we have a transfer bus. So here it's the case. In this case, as we have a transfer bus, we have to configure also the line disconnectors. And also we need the line disconnectors in case of parallel lines. Some further basic definition. What exactly is a centralized busbar protection, and in contradiction, what is a distributed busbar protection system? So let me read really first the definition. A centralized busbar protection, we speak about a centralized busbar protection, is the main protection function. The main protection function in a busbar protection is, of course, a busbar differential protection, and the analog measurement current value acquisition of the current are in the same device. It's important to understand it doesn't matter really where the binary signals, where the disconnector position, where the circuit breaker position, where the trip commands will be acquired or will be sent from. Really essential, important to speak about a centralized busbar protection is if the analog current measurement acquisition is in the same device. The distributed busbar protection. What is a distributed busbar protection? The main protection function, the busbar differential protection, and the analog measurement value acquisition of the current are located in different devices. And these different devices are typically located near to the process. So here in this shot, you will see And distributed busbar protection, the central unit will be this middle one here on the button, and the bay units or the merging units are located directly to the process, are connected to the primary current transformer. And in this case, we are speaking about a distributed busbar protection. So this was my first short warm-up. And now Nina will explain you a little bit more about the details of our concrete and detailed portfolio of busbar protection device. It's yours.
Yep. Okay. The moment we have short technical issue. 1 second, please. Okay. So thank you, Rainer, and good morning or good afternoon to everyone out there also from my side. The content of the next section is a short review to the SIPROTEC 4 solutions. I want to explain the possible solutions we offer with the SIPROTEC 5 portfolio and make a comparison of SIPROTEC 4 and SIPROTEC 5. After this part, we have time for a first Q&A session, and after that, we will have time for a short break. Okay, yeah, as a warm-up for my part, I want to start with a question to you as well. Where is the dedicated busbar protection applied in your company and which systems? Multiple answers are possible here. Please scan the QR code or copy the link from the chat and answer the question. We want to know from you if you have a busbar protection system for your medium voltage station or only in high voltage environment. Do you have SIPROTEC 4 devices in use or maybe already SIPROTEC 5 7SS85? Or do you have devices from other vendors and we need to convince you in this session from our SIPROTEC solutions? Okay, I give you some seconds to answer. Okay, I see Gert has already some results for me. So 80% say you need busbar protection in transmission. This is very typical, traditional application for busbar protection. Of course, there are high voltages, high currents. Here, the really damage can happen. But already 40% of you say you use this busbar protection also in the distribution medium voltage environment. Okay, yeah, I think this is also a growing development to use this. 20% have redundant dedicated busbar protections. Okay, not that much, but at least 20%. I see 50% already know SIPROTEC 4 7SS52, and 57% already have the 7SS85 in use. Very good. And I hope this session is interesting for you. And I see also 35% have, of course, some competitor systems. Okay, so thank you for participating. This slide may be familiar to some of you who already have experience with the SIPROTEC 4 7SS52. For those who are new to this, I would like to tell you a little bit about it. The 7SS52 is a distributed busbar protection solution. This means the process signal, in example, the current transformers, the circuit breaker, the disconnectors are connected to the bay unit. This is meant with the symbols on the bottom of the slide. The bay units are then connected to the 7SS522 central unit. So the 7SS522 is kind of the brain of the system, collecting and processing all the data from the bay units and doing the differential protection. The central unit in this case is based on the SIPROTEC 4 platform. The bay units are 7SS523 or 7SS525 devices, which are actually devices based on the SIPROTEC 3 platform. In this SIPROTEC 4 distributed approach, the bay units are connected via star connection to the central unit. The connection is done via multimode fiber optic cable. This is meant with the turquoise connection on the slide. The maximum distance between the bay units and the central units is 1.5 kilometers. The protocol for the communication between the bay units and the central units is the HDLC protocol. The measured value synchronization is done by the protocol, and no additional time synchronization is needed in the setup. The 7SS52 busbar protection is applicable for big substations with single, double, triple, or quadruple busbar systems with or without transfer bus with up to 48 bays and 12 busbar sections. In addition to the 7SS52 device, there are also other solutions in the SIPROTEC 3 or SIPROTEC 4 portfolio. With the SIPROTEC 3 portfolio, we had the 7SS60 device, which was a centralized busbar protection. This is the first device on the slide. Of course, the device is quite old, nothing we want to promote here. The SIPROTEC 4 solution for centralized busbar protection is the 7UT6. The 7UT6 is actually a transformer differential protection device, which can be used as well for busbar differential protection. This was necessary because before the SIPROTEC 5 7SS85, we had no other SIPROTEC 4 centralized busbar protection solution. The 7UT6 can be used for single busbars with up to 12 feeders without sectionalizer. The 7UT6 device are the ones in the middle of the slide. And of course, we have the 7SS52 in the SIPROTEC 4 portfolio. The 7SS52 is for complex multi-busbar systems in a distributed setup. All these devices are either already discontinued in the product portfolio or already announced for product cancellation. The 7SS60 was cancelled in December 2019. 7UT6 is announced for product cancellation in September 2024, and the 7SS52 is announced for product cancellation in March 2024. So it's time to think about a new solution with SIPROTEC 5. The good news is the migration path to SIPROTEC 5 is a quite easy one, because every device from the 7SS60 to the 7SS52 can all be replaced with the SIPROTEC 5 7SS85. The migration path is displayed with these turquoise arrows on the slide. The 7SS85 can be used in a centralized approach or in a distributed setup. For the distributed solution as bay units, you can use every SIPROTEC 5 protection device or, of course, the 6MU85 as merging unit in the feeder. So in SIPROTEC 5, we have one platform, one device, and one configuration tool. The SIPROTEC 5 7SS85 fits to all system configurations. You can realize the centralized configuration where all the process signal and currents are connected directly to the central unit. You can realize a distributed configuration where all the process signals are connected to merging units and the merging units are connected via process bus to the central unit. Or you realize a hybrid configuration where some data is collected by merging units and some of the process signals are directly wired to the 7SS85. So from the small switchgear, which is a compact design, in example, a gas-insulated switchgear, to the large air-insulated system, which like 40 bays, triple busbar with transfer bus and up to 10 bus zones are possible with the 7SS85. one device for all configurations, but of course the solution themselves are different. For centralized configuration, we use the 7SS85 centralized approach, quite obvious. For a distributed setup, you can use either the 7SS85CU distributed busbar protection or the 7SS85 IEC 61850 compliance solution. Oh, this was a bit too fast. The IEC 61850 compliance solution is fully integrated in the overall IEC 61850 process and station bus system architecture. It is a very flexible solution, but the engineering effort is quite high. The 7SS85CU distributed busbar protection solution is also a process bus solution based on the IEC 61850 protocol. There are flexible streams used, but with the fixed stream type IEC 61869-9. The sampling rate configuration is set to 4000 Hz and 1 ASDU. For the base, only proxy elements are available. The engineering is simplified following an automated process. It is additionally possible to configure user-defined GUIS messaging. With this solution, it is not possible to integrate third-party merging units. Okay, so in this case, the central unit is no longer the overall brain of the system. The bay units have some intelligence as well. You can maybe imagine it like this. With the 7SS85CU solution, the engineering effort is lower, and you can realize bigger busbar systems with more measuring points. For the hybrid setup, you must use the 7SS85 IEC 61850 compliance solution. Okay, now I want to dive a little bit deeper in each solution. This slide shows a single line diagram of a double busbar system with 20 bays. In this sketch, only 3 of them are drawn as an example. So typically, for the centralized approach here, the signals of the bays, that means the 2 disconnectors, the circuit breaker, and the current transformer, are directly connected to the 7SS85. Of course, enough current inputs must be available in the device. So with up to 20 bays, the device is a big one. In the 7SS85, there's a function group busbar with, in this case, 2 bus zones. Each busbar is 1 zone in this example. If there's, for example, a sectionalizer in the busbar, the number of bus zones is greater. In the function group busbar, the busbar protection algorithms are running. Check zone protection, and of course the busbar differential protection algorithms. For each bay, there's a bay, including all the elements that are physically actually there. So there are, in this case, a function group current transformer, 2 function group disconnector, a function group circuit breaker, and a function group voltage current 3-phase if additional backup protection functions are required. In the function group circuit breaker, some additional functionalities like the circuit breaker failure protection or end fault protection are included. The engineering process in Dixie 5 is to draw the single line diagram as it is shown here, create the 7SS85 with all these function groups and elements and functions you want to use, and then connect them to the elements in the single line editor. For the centralized busbar protection, the so-called significant features 9 and A to E are relevant. Rainer will explain later what the significant features are all about. And when I show you the device selection in the SIPROTEC 5 configurator at the end, you will get a better understanding. With the 7SS85 centralized, up to 20 measuring points and 6 bus zones are possible. The 7SS85 centralized is a cost-optimized solution because you need only 1 device. You can learn more about the centralized solution in our 3rd tutorial next year. Okay, The next slide shows the basic principle of a distributed busbar protection using the IEC 61850 compliance solution. Single line diagram of the system is basically the same. With this solution, up to 24 bays are possible. So in this case, in the sketch, the last bay is called bay 24. We are here talking of a distributed system, which means the process signals of the circuit breaker, the disconnectors, and the current transformers are connected to the merging unit and not directly connected to the 7SS85. The merging units are then connected by process bus to the central unit. In this case, here the communication topology is drawn like a star connection. We will talk about the possible communication topologies for distributed busbar protection systems in our third session also next year. The device structure of the 7SS85 in Dixie looks mainly the same as for the centralized configuration. In the 7SS85, there is the same function group busbar with the 2 bus zones and the very same algorithms as check zone protection and busbar differential protection. Also in this setup, we have for each bay, a bay with its function groups disconnectors, 2 times, a circuit breaker, and a function group current transformer. Optionally, function group 3-phase can be added if further backup protection functions are required. In a distributed system, it is also necessary to parameterize the merging unit. Just like for the base in the 7SS85, we need the same function groups. About the bay-related functions like circuit breaker failure protection, end fault protection, or backup overcurrent protection, some of them can be configured in the merging units, some of them in the central unit. In this example, the end fault protection function is configured in the 7SS85 bay in the function group circuit breaker. For end fault protection, this is the only possible solution. On the slide, the end fault protection 50EF is shown in the darker orange. The circuit breaker failure protection and the backup protection functions in the function group voltage current 3-phase can be configured in the merging units or in the central unit. They are drawn in a lighter orange on the slide. We recommend parameterizing all additional functionality mentioned before in the merging unit to keep the processor load in the 7SS85 on a lower level. In addition to the device configuration in Dixie, it is also necessary to make the IEC 61850 communication configuration in the system configurator for this solution. A description of these necessary steps can be found in the manual, but a good understanding of process bus is required in this case. The engineering effort is significantly higher compared to the centralized approach. With the solution, up to 24 CTs and 6 bus zones are possible for a distributed setup. The 7SS85 is fully integrated in the overall IEC 61850 process, and it is possible to integrate IEC 61850 compliant merging units from other vendors. Okay, this slide shows a hybrid busbar protection system using the IEC 61850 compliance solution as well. Hybrid means in this case that you have merging units for some bays in the field, and some of the process signals are directly connected to the 7SS85. This hybrid setup is only possible with the IEC 61850 compliance solution. In this sketch, bay 1 and bay 2 are connected to merging units, and bay 20 is connected directly to the 7SS85. For the hybrid setup, only up to 20 measuring points are possible. The configuration in Dixie is mainly the same as for the fully distributed IEC 61850 compliance solution. The only difference here is for the bay that is directly connected, you must put all the functionality to the bay in the 7SS85, just like in the centralized approach. The relevant significant features are the same as for the centralized approach and for the fully distributed IEC 61850 compliance solution. This slide now shows the 7SS85CU solution. This is a distributed solution for up to 48 bays. The difference between the centralized solution and the 7SS85CU distributed busbar protection is fundamental. For the centralized and the IEC 61850 compliant solution, you need to create all elements for the busbar differential protection and also nearly all the functionality for the base in the 7SS85. Single line elements of the base must be connected to the 7SS85 as well. In contrast to the 7SS85CU solution, really lives up to its name, distributed busbar protection. Here you put all functionality like breaker failure protection, end fault protection, backup protection function in the merging units. You connect the graphical elements in the single line to its representatives in the merging unit. After completing the engineering of the merging units, you must update the central unit in the single line configuration. During this update operation, the system configuration created in the single line editor is also created in the 7SS85CU using the representations of the connected base, circuit breakers, disconnectors, and measuring points. During this process, all necessary elements are automatically created in the 7SS85CU. These elements are visible in the project tree of the 7SS85CU and in the information routing. For the base, only bay proxies are created. They only have the most important functions and messages included and therefore have a lower memory consumption. This is necessary to increase the number of the measuring points from 24 to 48. The function group busbar with the protection algorithm is completely the same as for the other solutions. This is a very important point. Communication between the bay units and the central units is also based on IEC 61850. In the IEC 61850 system configurator, the assignment of the physical measuring points of the merging units to the central units in the sampled measured value view must be done. For this purpose, a script is provided which automatically performs the assignment according to the specifications from the single line diagram. The engineering effort is therefore significantly lower than with the IEC 61850 compliant solution. With the 7SS85CU solution, a setup with up to 48 measuring points and 6 bus zones is possible. Also, in the 7SS85CU solution, every SIPROTEC 5 device can be used as a merging unit. The requirement to the device hardware of the 7SS85 is to have an Ethernet BD module for 16 measuring points each. With 3 modules, one comes then to 3 times 16 measuring points, which are altogether possible. Here it is important to know that with the option with 60 measuring points per module will be possible from version 9.14. Until now, it was 15 measuring points per module. You can learn more about the 7SS85CU solution in our last tutorial next year. Okay. In the next 2 slides, I want to compare our SIPROTEC 4 solution 7SS52 with the SIPROTEC 5 solution 7SS85. In the system family, the 7SS85 is fully integrated in the SIPROTEC 5 platform. With the 7SS52, the central unit is a SIPROTEC 4 front end, special designed for busbar protection. The bay unit is a SIPROTEC 3 device. The topology in the 7SS85 can be a centralized setup, distributed setup, or even a mix of both variants. With the 7SS52, it is always a distributed setup. If we compare the communication redundancy, we can offer with SIPROTEC 5 redundancy protocols like PRP or HSR. But you can, of course, also use star mode without any redundancy. With the 7SS52, the bay units are always connected via star mode to the central unit. one too fast. The time synchronization is in SIPROTEC 4 done by the protocol. In SIPROTEC 5, you can use, since version 9.20, the integrated Grandmaster clock. No additional equipment is needed in both cases. Here we go. The requirements for the current transformers are the same for both devices. So for the minimum saturation-free time, we need a value greater 2 milliseconds, a transient and a transient dimensioning factor KTD of 0.5 in both times. We will talk about CT dimensioning in the third tutorial. About additional functionality in the 7SS85, we have the really great benefit that you can integrate all the SIPROTEC 5 platform functionalities to the SIPROTEC 5 device that you want to use as a merging unit. The typical functions for busbar protection, like circuit breaker failure protection and end-fault protection, are of course available in SIPROTEC 4 and SIPROTEC 5. The protection algorithms are completely the same in both devices. We have the 3 self-adapting algorithms for the differential protection: the 1 out of 1, the 2 out of 2 algorithm, and the algorithm with the filtered measured values. And this is really also a benefit in the SIPROTEC 5 device, because since we use the same algorithms, we benefit from all the experience with the SIPROTEC 4 7SS52. If you are already familiar with the SIPROTEC 4, don't worry, you don't have to learn something new. If you want to learn more about protection algorithms, please join our second tutorial in January. The tripping times of SIPROTEC 5 are a little bit lower than with SIPROTEC 4. In the 7SS52, the minimum tripping time for high current internal faults is 15 milliseconds. For lower currents with DC offset, higher tripping times are possible. With the 7SS85, tripping times of 7 milliseconds with the centralized system and 10 milliseconds for the distributed systems are possible. The maximum number of measuring points is 20 for the 7SS85 centralized and hybrid solution, 24 for the distributed IEC 61850 compliant solution, and 48 for the 7SS85 CU solution. For the 7SS52, the maximum number is also 48. The maximum number of bus zones are 6 for the 7SS85 centralized, the IEC 61850 compliant solution, and 20 for the 7SS85 CU solution. Same with the maximum number of couplers. For the 7SS52, up to 12 bus zones and up to 16 couplers are possible. About the safety and supervision functionalities, they stay the same. There is the integrated check zone functionality as an additional trip criterion, and there are comprehensive supervision and control functions like the current sum supervision. The engineering is in both cases based on the graphical engineering in the single line editor. For the configuration and operation, Dixie 4, respectively Dixie 5 is used. For the online monitoring, we can offer for SIPROTEC 4 and SIPROTEC 5 single line based view via display or Dixie 5. Here you can check the current values, the differential values for each zone, and the disconnector image with the status of all disconnectors. For the 7SS85, there's additionally the web browser available. The topic cybersecurity is definitely a selling point for the 7SS85. Since the device is a part of the SIPROTEC 5 family, platform functionalities like role-based access control and IEEE 802.1 based network authentication can be integrated. With the 7SS52, we can only offer basic password security. Another benefit, which is worth to mention here, is that for SIPROTEC 5, 7SS85, we have the possibility of virtual testing with our SIPROTEC 5 digital twin solution. It is possible to simulate the centralized and the distributed solution with the digital twin. Okay, that was a very long monologue from my side. I hope it was possible to follow and also not too boring. We have time for some questions now. Michaela, will you please help me with the Q&A part?
Yes, I will, Nina. It was definitely interesting for me. I think I learned a lot on Busbar protection, and I'm glad that we have experts for that. And I already see some questions there. And I'll take a step closer and see. Yeah, Rainer, thanks for joining us here, because these questions arose in the last hour of this presentation, so it was the two of you. And yeah, let's start with one I just see there coming from SV on the rather top of the list. So, and Gerhard, as always, when we answered the question, it will definitely be helpful if you put them into answer. Thanks a lot for that out there. So SV wants to know, can we use high impedance function that built in low impedance busbar protection with MUs? And if yes, how? Who takes on that?
Okay, I guess this will be my turn. Yes, on principle, it's possible to build in high impedance busbar protection. It's a merging unit. I think you simply need a simple overcurrent protection to implement and high impedance busbar protection. Of course, you have to do all these complicated calculations, but in principle, it's possible.
Thank you. And we just jump to the next question. Why is the free time of saturation, or why should the free time of saturation should be greater than 2 milliseconds? I think that was on your list, Nina, right?
Yeah, maybe I take this one. Yeah, we need these at least 2 milliseconds to make a clear decision. Is it an internal fault or an external fault? And yeah, but these 2 milliseconds are really enough for the trip decision. So I think it is already a very small value.
Cool.
Maybe one additional, this will be explained in detail in our next tutorial. I guess it is my part of the protection algorithms. And one more detail to make it more interesting and that you will join also in general is we need these 2 milliseconds to block on time the 1 out of 1 algorithm. And in generally, you will learn what is exactly the 1 out of 1 algorithm.
Oh, this webinar makes me curious. And I'm happy that I already know I will join those as a moderator. So I think you will need to put those dates in your calendars too. But let's continue this question round. So just freshly rushed in from FP, are there specific things to be considered when choosing a 7SS85 in GIS substations or respectively in AIS substations?
I guess this answer will be, this question will be answered mostly in my next part of my webinar. What are the basic questions you have to ask you?
So yes,
please wait 30 minutes and you will get most likely the answer.
Oh, directly after the break. Great. So just not for the next webinar, but just after the short break.
In the second part for the tutorial today.
Perfect. Okay, that's a long question. I will read it to you and the experts have the chance to read it too. So AY wants to know how many bays are possible in total in the 7SS85 CU distributed. Mentioned in slides is 48 bays, but earlier in each, it's ETH or it's extra high voltage, I think. No, Ethernet BD ports. Module, yes. 15 bays were possible. If total 3 BD ports, so total 55. I think I listened into that. You mentioned that it's now 16, right? Coming from version 9, right?
Exactly, 9.40.
Okay.
Yeah.
Yeah, so there is a change in the counting of numbers, but that's correct. 3 times 15 is just 45, but starting with version 9.40, it's 3 times 16, and now it's up to the 48 base. And I think now I need the next question.
One additional, this version 9.40, we have discussed about it, and we decided to mention 48 and 60 per PT module because it will be released with the version 9.40, and this 9.40 should be released I guess end of this week. So we decided let be us up to date. Let's here really announce this new value, which will be valid latest end of this year.
Okay, thanks. So just fresh from the press, kind of. All right, next one from AA. Do we have any provision to identify bay level CT supervision apart from differential supervision?
Bay level CT supervision.
And
I'm not absolutely clear. You, Nina?
You neither. So, AA,
maybe one assumption that you mean one from this AD, analog digital supervision, this fast current sum supervision, and the differential supervision, but I am not sure. Maybe you can explain a little bit more. Do you mean this with bay level CT supervision, the AD supervision, the fast current sum supervision? So I'm not sure.
I think we'll take this question offline. We have the contact data afterwards. And if Rainer doesn't and Nina don't answer you, just come back to them and ask the experts directly. I think they will get in contact with you on this question. So to find out more on that. And then the next question is coming from DR. Can we upgrade only BU of 7SS52 with a 6MU or 7SS85?
Yeah, maybe I answer this. No, it is not possible to just exchange the bay units. You also have to exchange the central unit. So it is not possible to mix SIPROTEC 4 and SIPROTEC 5 systems here.
You got the question. That's why I have experts right here. And then I see the question from RP, and if you scroll a bit, that'll help. Thanks a lot. So 20 bays or 20 CTs for centralized solution. Does that mean at maximum 5 bays? Oh, where was that?
No.
No?
You take
no, 20 CTs means really also 20 bays, because if we are speaking about one CT, we mean one measuring point. Also CT and measuring point, it's every time the same expression for us. And one measuring point, one CT, consists of 4 analog current inputs. That means 3 times the phase A, B, C, and the neutral current. So in reality, there are 80 current inputs. 20 CTs means 80 current inputs.
Okay, thanks. And then the next one is coming from MK, and MK wants to know, do you see GIS switchgear or indoor switchgear needs busbar protection if an arc protection is implemented?
Yes. I think arc protection not really completely can substitute dedicated busbar protection. What we are offering is really a very good protection if you combine the arc protection together with the busbar protection. So, for example, the arc protection watches a certain bus zone, and if this arc protection really picks up, this arc protection will have an external trip directly to this bus zone and will immediately trip the bus zone. And but so far, I do not know any customer who really trusts completely arc protection for busbar protection. It's too unsure from my point of view. But it's a very good option to combine arc protection with busbar protection.
Thanks for jumping in on that. Oh, that's an interesting one also for me, because MP wants to know, what does XMZ mean?
Yeah, so I take this question. Was on my slides, on the comparison slides. This means overcurrent protection. That is some summary of all overcurrent protection functions.
Okay. Thanks. And then another question from an SV. Can we use the busbar protection with several MUs instead of the line differential relay between many substations?
Can you use busbar with several merging units instead of the line? So are you sure?
So between more substations, long distance?
Should it mean to have some kind of to replace line differential protection with busbar protection? So in general, this is not possible because line differential protection, you need communication of more than 100 kilometers. So here we have a maximum of 2 kilometers. And also with line differential protection, you have to take care of different angles between the voltage and different angles of the faults. And this is not considered in the busbar protection device. Busbar protection device, we consider only 0-degree angle or 180-degree. This makes the busbar protection much faster. And also the CD requirements are lower. But on the other side, it's not so easy to replace completely line differential protection with busbar protection.
Thank you. Yeah, but nevertheless, an interesting question.
But for small lines, 1 kilometers, where really the capacity of the line is not so very important, it will work.
Okay.
For really small lines, you can do it.
So once again, depending on the case.
Yes, yes.
Okay, thanks. And another question coming from MP. Can you explain how much the additional CPU usage is of a bay protection device that is used for a PB connection? Oh, thanks. Connection to the 7SS85CU and as backup protection device. So additional CPU usage. Do you have any value there? Or
so this means the additional CPU load in the bay unit, in the merging unit, to make communication with the 7SS85 center unit. I can't say an absolute value, but it's quite low because most of the work will be done not in the CPU itself. It will be done on this 800BT module. So I guess, yeah, maximum 5%. It's really not much.
Okay. Thanks.
So it's no problem if you have a complicated high CPU loaded distance protection in the merging unit. The additional CPU load for the communication to the busbar protection is really very small.
Thanks a lot. So, and then we take another question from MZ. In the slides, you stated for the 7SS85 up to 6 bus zones, and you can have up to 20 bus zones. Is there a reason to state only 6 bus zones?
Can you answer?
I guess. So I'm sorry, Nina. This was maybe also in your slides really at one point a misunderstanding. But you have said it in correct way on several other times. So the maximum 6 zones is possible with the 7SS85 centralized and the IEC compliant solution. And the 20 zones are possible with the 7SS85CU solution. Maybe it was mixed at one time. And the background here is also that only in the 7SS85CU, because we shifted a lot of functionality to the merging unit, to the bay units, we have really enough CPU power and memory to deal with up to 20 bus zones. And this is not possible in the centralized busbar protection, where it's possible only to up to 6 zones.
Oh.
I hope.
So different configurations there.
Yes, so, and a different maximum scope of the busbar protection.
Thanks for the clarification on that. And I think I'll take 2 questions in one. If we already have any reference projects using the new system in the Gulf region, or if we talk there about the pre-qualification in Saudi Arabia as a centralized or a distributed system. Do we already have something there? Or do you volunteer for a pilot project?
Yeah, I guess I will not here really say really concrete project names, but we have a lot of distributed Busbar protection systems running now, at least in Oman, and we have already at the moment in commissioning, really in the phase-up phase here, also in the United Arabs. So we will have a lot of reference projects.
Afterwards. Yeah, sometimes it's difficult to complicate the reference projects. We know about them, but yeah, you know about customer consent on telling kind of secrets, whatever.
Yeah.
Yeah, but we have them. And then another question from SV. So does Busbar protection still need CTs for both sides of the bus coupler or bus section bay?
Yeah, maybe I take this one. If you have two CTs in the coupler, you can use the the coupler differential protection, to reach a higher selectivity in this area, but it is not mandatory to have them.
Okay.
So I'm a little bit surprised. Does Busbar protection still need? So it sounds a little bit that in previous time, like in the 7SS52, it was mandatory to have two CTs in a coupler, but it was possible with only one CT also in our old 7SS52. So answer, no, it's also possible with one CT.
Okay. I think the question I just see there from DR we already answered. And ME wants to know a bit more on the difference between the hybrid and the centralized solutions.
Okay, yeah, I can say something about that. The hybrid solution is kind of a mix-up of the centralized solution and the distributed solution. That means some of the process data from the field is directly connected to the 7SS85, and some current transformers, some fields are connected to merging unit, and these merging units are connected then to the 7SS85. So it is a mix-up of centralized and distributed.
Oh, okay, thank you. And more question. I think that's a vivid round, but that's why we took some time for it. So BP wants to know, is the stabilizing busbar current in the 7SS85 also time delayed with low pass filter? So with 65 milliseconds time delay? And does this apply to bus and check zone stabilizing current? I need an expert there. I don't even get the question, but I hope you do.
Also the expert are a little bit confused.
Okay.
So 64 milliseconds time delay, I do not know. Of course, we have in the hardware, we have low pass filters. The measurement acquisition, of course, has several filters. But I'm not aware about any 64 milliseconds time delay.
So I think BP, this is also a question we might to take offline and check again or get in direct contact there. It might be easier on a one-on-one talk than in this general round over here. But nevertheless, thanks for asking. And so we see if the other one is a nice one for you to answer. So is check zone in the 7SS85 also circuit breaker status dependent?
No, it is not. So that the check zone works independent of the disconnector image and of the CB status. This is an additional security against a wrong status, a wrong position value here.
Okay. And then one more from MP. Why can't 50 EF be configured in the field units?
The answer is it can be configured in the field unit for the 7SS85 solution, but we have it's possible only for the 7SS85 solution, not for the IEC 6150 compliance solution. This has a lot of internal reasons why we can't implement this also for the IEC compliance solution. But I think the end-fault protection in the IEC compliance solution is available in the 7SS85 central unit. But 7SS85CU fully distributed, it is possible as a field unit.
Oh, okay. So once again, depending on the configuration and the implemented hardware. Thanks a lot. And we take one more question from MZ. In the present, oh, that's a long one. Listen in. In the presentation of migration concepts, you did not mention that there is a replacement of the SIPROTEC 4 solution with 7UT6. So in 7UM85, there is an 87B functionality implemented for small, in brackets up to 5, base systems, so for small systems. And you do not want to mention this. It's okay. Strategic, internal question. So now I'm confused. Is there a question or not? Do you see any question, any chance to answer that?
Okay, he's an internal. He already gives the answer. We will not mention it. But I give a clear answer. The Busbar Protection in the 6MU85 is really no replacement of any Busbar Protection here migration path. The Busbar Protection in the 7UM85 is only really to be used as a backup protection and not as a really full Busbar Protection. And it's also a limited functionality compared to the 7SS85.
So it was an important information here. It's just a backup. It's not a complete solution. You can use it, rather small, but it's not what we suggest, right? Okay, thanks. So thanks for mentioning. And my dear colleagues, if we talk internals, you know how to contact Rainer and Nina, just to make that sure. But we don't have any huge, we talk as open as possible in here. That's also true. And I think we'll take one last question before we jump into the break, right? If I take care of the time or remember that correctly. So one last one from AMV. Can we use a 7UT86 for single busbar protection? So with using the auto transformer differential function?
Yes, and
experts smiling.
Officially not. The Busbar Protection officially is not supported because we have even for single busbar protection, we have the 7SS85. But if you absolutely want, you can do it, but it's not officially supported. Full stop. Okay. No further comment.
Okay. So just on your own risk. Now you can expect approximately almost 1 hour with Rainer talking more details to you and telling more details to you. Rainer, will you join me on stage? Because I'm not the expert, you are. And so this stage is yours.
Yes, thank you, Michaela. Next part will be to explain really the theory, how to select really the best and proper fitting 7SS85 busbar protection device to your substation, to your requirements. Before I will start, just one wrap up from our questions I have answered. We had a short discussion, and maybe I understand these questions about whether it will be possible to replace line differential protection by busbar protection. This is, of course, not possible. This won't be possible, since I have explained. But of course, what is possible, as each modular SIPROTEC 5 device can be used as a bay unit for the distributed busbar protection. And so, of course, you can use a line differential protection device, a 7SL86, 87, with the integrated line differential protection. And then you can integrate it really in the functionality of the bay unit of the distributed busbar protection. This is possible to take a line differential protection device as a bay unit for the distributed busbar protection, and then you have the line differential protection. Maybe this question was more in this direction. Okay, let's start. Device selection theory. The practical part will afterwards Nina show to you. Before I will go into details how to configure the correct device, for a small wrap-up, what are the advantages and what are the disadvantages of the three basic device types of the centralized busbar protection, of the IEC 61850, compliant distributed busbar protection, and the full distributed busbar protection, the successor of the 7SS52. Let's start with the centralized busbar protection, the 7SS85 Thunderbird. What are the advantages? It's very easy to engineer. DXC5 during this engineering brings us really enhanced consistency checks. So it will be nearly impossible to bring a wrong configuration to your device. As it is a centralized busbar protection, you have only one device, only one CPU instead of several CPUs, instead of several devices. It's cost optimized. So centralized busbar protection is mostly, in each case, also the best one in case of price. Up to 20 CDs are possible. This may be a disadvantage compared to the distributed busbar protection, but compared to really all other competitors of busbar protection devices, this is really a big advantage because we are really the only vendor which allows a centralized busbar protection with up to 20 CDs, 20 current measuring points, means 80 current inputs within one device. We can deal with up to 6 bus zones, and already said it's price optimized due to a low hardware effort. What may be some disadvantages? Now we come a little bit also to the questions I said I will answer during my next part of this presentation. It may be a high wiring effort because all the binary inputs, all the cables of the binary inputs, of the binary outputs, of the CDs must be concentrated at one device. So it's a quite high wiring effort. Here, very important, if we have a large air-isolated substation, we will have a risk of a high CT burden because these long cables from this decentralized systems from one bay, which may be 200 meters away from the center unit, you need a very long cable, a very long wire, and this leads to a high CT burden. And this high CT burden can lead into an earlier saturation of your CT. So the centralized busbar protection is only suitable really mostly for GIS substations. Suitable for compact substation, as already said. The IEC 61850 compliant solution. Advantages, fully integrated. It can be fully integrated in the overall IEC 61850 process. A big advantage, also in contrast to the 7SS85 that the integration of third-party merging units means merging units from GE or ABB or anything else can also be used as a bay unit for the distributed busbar protection. We can use this hybrid setup, as Nina already has explained. Hybrid setup, once again, means a combination of both distributed approach and also a centralized approach. Typically, we are using a distributed busbar protection, locate the 7SS85 device in a coupler, and we make a centralized wiring to the coupler, to the 7SS85, whereas all the feeders will be assigned by the distributed approach. And this is a common general advantage in our 7SS85 SIPROTEC 5 distributed busbar protection. Each SIPROTEC 5 device can be used as a merging unit for the distributed busbar protection. For example, also an 7SL8, 7SL86, 7SL87, a line differential protection, but also distance protection, transformer protection, each device which is in the SIPROTEC 5 portfolio. A little bit the disadvantages. It may be a quite complex and fault-prone engineering. Maybe not so much the assignment of the current information to the device, but to do all the disconnector positions of the several disconnectors, of the positions of the circuit breakers, the trip commands, and wiring this via a goose engineering. It's not so easy job. It can be done, it's not complicated, but the engineer has to be very concentrated. The setup is only for a maximum of 24 CDs, a maximum number of 24 bays. And as we are using the same device as a centralized busbar protection, it's also limited to up to 6 buzzons. Let's come to the 7SS85CU, the fully distributed busbar protection. It's very easy to engineer, especially in contrast to the IEC 650 compliance solution. It can also you can also use very enhanced consistency checks. This is associated, of course, a lot of that it's not, let's come in the same step to the disadvantage, that it's not, you can't use third-party merging units for the 7SS85CU solution. And this comes a lot with this enhanced consistency checks, which are, of course, not possible if we are using a device from a third party. If we are using a merging unit from GE, a merging unit from ABB, they have their own engineering tools, and it's not possible to integrate them with the same consistency check like our SIPROTEC 5 merging units. Up to 48, beginning with 9.40, which will be released hopefully during this week. There will be 48 CDs possible, up to now only 45 CDs. There are up to 20 buzzons possible with the 7SS85CU solution, and the same like in the IEC 61850 compliance solution, you can use each modular, I forgot this on the slide, very important, you can use each modular SIPROTEC 5 device as a merging unit, as a bay unit for the distributed busbar protection. How could really and way a decision matrix be for the correct device selection to select the correct type of 7SS85 busbar protection? The first question is, what are the number of CDs? What are the numbers of measuring points? Are they higher or lower than 20? And what is the number of independent buzzons? Are they higher or lower or 6? If you have more than 20 CDs, and if you need more than 6 buzzons, there's no doubt about it. The only solution could be to use a 7SS85CU. Sometimes you may have the possibility to split the substation. If you have a sectionalization coupler, you can split it into 2 systems. But typically, in generally, you should use more than 20 CDs, more than 6 buzzons. Please use the 7SS85CU solution. Then next questions. If you are below 20 CDs and if you are below 6 zones, then you have to ask, is my substation a compact, small, gas-isolated substation, or do I have a large air-isolated switchgear? If we have a compact GIS, okay, we can deal with a centralized busbar protection approach. If it's a large air-isolated switchgear, I have already explained, a very big substation, you need a long of cable, a long distance of wiring of the primary CDs with the CDs in your device which means a high burden of the primary CD. And such a high burden of the primary CD could lead into an earlier CD saturation, which would risk a wrong tripping in case of an external fault. This is very important. Okay, if we have a large air-isolated switchgear, so that means we need for sure a distributed busbar protection, and we can ask more the questions, do we want to use a hybrid configuration? Do we want to use a mix of a centralized busbar protection and a distributed busbar protection? If yes, we should use the IEC 61250 compliant solution. If not, then you may ask, okay, does the customer or do you want to use also third-party merging units, maybe also from NARI, GE, or anything else? If yes, you have also only the chance to use the IEC 61250 compliance solution. If not, and you want to have an easy engineering, you should use the 7SS85 CU solution. Or, of course, you can every time shorten this decision matrix. You are the user of a 7SS52. You are very, you loved your 7SS52 systems and you want simply a successor of the 7SS52. And then you can go directly the same approach. Okay, I want to have a successor of the 7SS52, and then you will immediately go and use the 7SS85 CU solution. Okay, let's go more into the details. We have here on the one side the 7SS85, the centralized, with certain significant features from 9 and from A to E. And we have new types. We have the 7SS85 CU solution with also special significant features. This you will see on the right side on the slides. So let's go more into the details. Let's explain a little bit what different types of 7SS85s are available. Let's start on the right side. We have the significant feature 9 and A, B, C, D, E. These are the significant features for the centralized busbar protection and also for the distributed IEC interoperable IEC 650 compliance solution. We have here the significant feature 9, which can deal only with one zone. So only one bus zone, only one single bus. We have A, 2 zones, 2 independent single buses, and we have B, which has also 2 zones, but it has a disconnector image. This means with significant feature B, we can deal also with one double bus. And then we have the C, which is also without disconnector image. So this means 6 independent single buses. We have the significant feature D, which means 6 zones with disconnector image. This means this would allow a triple bus bar with a sectionalizer inside, for example, or a double bus bar with a sectionalizer in a transfer bar or anything else. A very special significant feature is a significant feature E, which also allows 6 zones and has a disconnector image, but in this very special functionality, you have only the circuit breaker failure protection available. You don't have a busbar differential protection. This is a special requirement to use a busbar protection device, the 7SS85, to use only the disconnector image of the busbar protection device to clear the associated bus zone in case of a circuit breaker failure. And also you see here how many bays in the distributed approach you have available. With significant feature A, we have 4 bays included. With C and D and E, we have already 6 bays included. The hardware variants are only, which you will see on the right of the slides, the hardware variants. Oops, Now I don't see any slides anymore. Now I see it again. The hardware variants are just how to say, successions of a starting point of your correct configuration, of your correct hardware configuration. So we will come to it later. And last but not least, we have the significant feature for the fully distributed solution for the 7SS85CU. These are the significant feature F, which is for only 6 zones. Once again, no disconnector image available. And okay, G, the CU for up to 20 zones. Not very common, this issue. Very seldom to have really 20 zones without a double bus bar or triple bus bar. We have once again CH, the CU for 20 zones disconnected, and circuit breaker failure protection only. That's the same what I have explained with this with the significant feature E for the centralized bus bar protection. And you have the significant feature for the 7SS85CU with a disconnector image, the J with 6 zones, and the K, the biggest one, with 20 zones and disconnector image. And very important, with the 7SS85CU solution, it is always a distributed approach. It's no way to use it as a centralized bus bar protection. There are no bays necessary and therefore also no bays included. Okay, finding a correct device configuration is split into 3 parts. First part, the 7SS85 centralized, find a correct device configuration for the 7SS85 centralized bus bar protections. Next, of course, will be find the correct configuration for the 7SS85CU, and finally find, which is more or less a combination, find the correct devices for the IEC 62160 compliant distributed solution. The most complicated, because the most things are new, will be the explanation of the centralized bus bar protection. But if you know the centralized bus bar protection and how to find the correct configuration for a centralized bus bar protection, it will be quite easy to find the correct configuration for the other ones. So let's concentrate in the first step to the centralized bus bar protection. What questions have to be answered? How many bus sections must be considered? Is a disconnector image necessary? I will explain it later in detail. How many measuring points and how many bays? This is quite often similar, but can be quite often also different. Do we need a circuit breaker failure protection? Do we need end-fault protection? And how many binary inputs, binary outputs are necessary to handle the whole configuration? Let's start with the bus sections. Double bus bar here is a small example. It's a good idea to remember this example very well, because exactly this example later Nina will configure on a practical case, in a practical exercise in the SIPROTEC 5 configurator. Here we have a double bus bar with a coupler. How many bus sections do we need? 2 bus sections. You can see here we have the double bus bar. Here's bus bar 1, bus bar A. Here is colored in blue. And the bus bar B or bus bar 2 is colored in red, I guess it is. And as it is a differential protection, the split between bus bar A and bus bar B will be done in the coupler, and really the split of these 2 bus bars will be exactly at the current transformer. And here you could also see already an example, a coupler with only 1 CD. 2 CDs would be also possible, but here we have an example with 1 CD only. So here, example, how many bus sections do we need? In our example now, we need 2 bus sections. disconnector image. Do we need a disconnector image? That's maybe sometimes for somebody who comes from the 7SS52 and is new to the 7SS85, a little bit different. When do we need really a disconnector image in our device, and when can we buy the cheaper one without disconnector image? So, depending on the disconnector status, the current will be assigned according to the according measurement system. If you see the feeder on the left side, the busbar disconnector to busbar B is closed. So this means this feeder current will be assigned to busbar B. On the other case, the feeder on the right side of the coupler is signed in blue. Here the disconnector to busbar A is closed. So this current will be assigned to busbar A. This means we every time need a disconnector image when a feeder current can be assigned to different bus zones, to different bus sections. So don't look, if you want to answer these questions, don't look if you have any couplers. Couplers doesn't matter. Do we have one feeder, and one feeder is enough, where with disconnectors we can assign the current of this feeder to different bus bars, to different bus sections. In this case, we need a disconnector image. So in our case, don't forget, we need a disconnector image. Okay, the disconnector status will be recorded by auxiliary contacts. We will just also explain in detail a lot in our second tutorial. And we have, like in the 7SS52, this not open is closed treatment. This means also that especially in the sensorless busbar protection, where sometimes we may not have so many binary inputs, that also a binary input, that also one binary input may be sufficient to make this not open closed treatment. But it's very important, if we are using only one binary input, we have to use a normally closed contact of the disconnectors, which gives us a clear signal whether the disconnector is high or not, whether the disconnector is open or not with a high signal. Of course, only in the case we have two binary inputs, we can really make a supervision of the transition time, and we can also making if we have a runtime error or anything else. But it's important for our example here, just to make some exercise and to state it's possible in principle, we will use only one binary input for the disconnector position. End-fault protection, we have to know whether we need an end-fault protection or not, in case that we have to pay function points for the end-fault protection functionality. The end-fault protections, once again, outlook to our next tutorial. The end-fault protection will shift the protection range from the current transformer to the open circuit breaker. And this depends on the location of the CD, on the location of the circuit breaker or the location of the CD relative. It prevents from an over or an under functionality. That's for the feeder bay, and in the feeder bay, it also gives us a transfer signal to the other end of the line to clear the fault from the other end of the line. In a coupler bay, the end-fault protection will also protect, in case of an open circuit breaker, the area between the current transformer and the open circuit breaker. So this means also in this case, we should consider one end-fault protection in each feeder bay, and very important, also one end-fault protection for the gray zone protection in the coupler. Okay, we have learned now we have this example of a double bus bar with 4 feeders and one coupler with 1 CT. And the proposal is so we can use a significant feature B, which deliver us 2 zones. That's enough for our example. And also brings us a disconnector image. We need also a disconnector image. And very important, we have 4 bays inclusive together with the significant feature B. And it's also the proposal to use standard variant 2, which also brings us 16 current inputs. Here we have really the single current inputs. So the 16 in this case means we have 4 bays, 4 measuring points included, and binary inputs and binary outputs. But to make it also obvious that it's only a proposal, you can start also with the standard hardware variant version 1. And we will do this in this case. We will start with significant feature B. We will select a 7SS85 with significant feature B. And we will start our configuration with a hardware variant version 1, which brings us 12 current inputs, which means 3 measuring points, 3, all in all, 13 binary outputs and 15 binary inputs. Okay, how many we need all in all? Let's count. Bays, we have already 4 bays inclusive, so we can cover with this 4 bays the 2 feeders left to the coupler. We can cover the coupler bay, and we can cover 1 feeder bay right to the coupler. So we need 1 additional bay. So we have to bay by function points 1 additional bay. That's this red one. CTs, we need all in all 5 CTs. So we have already 3 CTs with the hardware variant version 1. So we have to take care that we have 2 further CTs. Oops. Let's count the number of necessary binary inputs. So we have, what binary inputs do we need? We need the circuit breaker close command. That's very essential and important for the end-fault protection to bring really right in time when the circuit breaker will be closed, the current back to the measurement system. So that's very essential. Once again, will be explained more in detail together with the end-fault protection. But really, it's very important not to forget to use the CP close command for the end-fault protection. So if there is any wrong triggering of the busbar protection, and so typically, as a PLM for busbar protection, typically 1 or 2 times a year, there's a high upset in our organization, wrong triggering of a busbar protection, and nearly at every time it was a reason that they forgot they have end-fault protection, they have an external fault, they have an automatic reclosing, and they forgot to use the CP close command, and you have a wrong triggering of the busbar protection because the end-fault protection was deactivated too late because of the missing CP close command. The auxiliary contacts of the circuit breaker, you need, okay, I forgot the CP close command. Here, 1 binary input is enough, both for the feeders and for the coupler. The circuit breaker auxiliary contacts for the position of the circuit breaker, which is necessary not for the disconnector image, but for the end-fault protection. We need 2 binary inputs in the feeder, and in the coupler, 1 binary input may enough, because here the coupler current is not part of the checkzone anyway, so here the security requirements may a little bit lower. We need 1 binary input for each feeder to activate the circuit breaker failure protection in the feeder. Typically, you have no external started circuit breaker failure protection in the coupler, so we don't need it. And for the disconnector image, we have 2 busbar disconnectors in each feeder. And as we said, just to say that it's possible. So we are using only one binary input in this example. So we need 2 binary inputs per feeder for the 2 binary inputs per feeder for the busbar disconnectors. Binary outputs. How many binary outputs do we need? We have this transfer signal from the N-fault protection to send a trip signal in case of a fault between the circuit breaker and the current transformer to the other end of the line. So we need 1 binary output, typically not necessary in the coupler, because you have no other end of the line in a coupler. And typically for the circuit breaker trip command, we are using 2 binary outputs. So in total, we need for this configuration 28 binary inputs and 40 binary outputs. Function points, already said. N-fault protection in each feeder and also in the coupler. So 5 points here in the sum. Circuit breaker failure protection. Here we assume only a 3-pole circuit breaker failure protection. This means 15 points in each feeder, no function points in the coupler. And for the additional bay, we need 50 function points for this 1 additional base. Already 4 bays are included, as you remember, with significant feature B. So in total, 28 binary inputs, 14 binary outputs, and 135 function points. The next function point class will be 150. In the meantime, of course, you could also use, together with the function point manager, the class hash functionality, and then you can work exactly with the 135 function points. So this, you can see here with hardware variant version 1, we can more or less cover the 3 feeders and the 1 coupler. And to have enough binary inputs, enough binary outputs, also for the missing 2 feeders on the right, we extend the configuration each we extend the configuration with 2 IO201. Then we have the configuration really of 5 measuring points, of 31 binary inputs, and of 25 binary outputs, which is yes, absolutely sufficient for this small double busbar. Okay, next slides I really like, because it gives also a little bit to you the possibility to check whether you have understood all the things I have tried to explain now. Here we have a small configuration. We have a single bus with a sectionalizing coupler in between. So check it by yourself. First questions, how many bus zones do we need? I give you every time a little bit time. Okay, the answer is of course 2. 1 bus zone left to the sectionalizing coupler, 1 bus zone right to the sectionalizer. Do we need a disconnector image? Please remember, when do we need a disconnector image? We need a disconnector image when it is possible via disconnectors to assign a feeder current to different bus zones. And this is definitely not possible here. We have no busbar disconnectors at all. Each feeder is directly assigned to a dedicated bus zone. So we don't need a disconnector image in this case. How many bays do we need? Will be interesting. There are 8. Let's count. See 4 feeders on the left side of the coupler, the 3 feeders on the right side of the coupler, and for the complete coupler, even if it's a coupler with 2 CTs, we need only 1 bay. So all in all, we need 8 bays in this example. How many CTs do we need? course, it's 9. We have 8 bays, but for the coupler bay, we need 2 CDs, so we need 1 CD more than bays, so we need all in all 9 CDs. Okay, now it will be interesting. How many will give here the answers correct? That's a double busbar. I see some couplers, and I see also sectionalizing couplers. I see a sectionalizing coupler. I see a sectionalizing disconnectors. So first, how many buttons do we need? I guess this hopefully is quite simple. It's 4. So 2 buttons on the left side of the coupler and 2 buttons on the right side of the coupler. Do we need a disconnector image? Once again, we have busbar disconnectors, so the feeder current could be assigned to different buttons. It could be assigned to the upper busbar or to the lower busbar. So it's quite clear. We need here a disconnector image. Number of bays. Now I give a little bit time. So please count the number of bays. Okay, there are 11. I guess quite a lot of you may answer also, we need only 10 bays or we need only 8 bays. So let's count in detail. So here we have 3 bays. Here we have 4 bays. That's 7, 8, 9. And now it will be interesting. That will be 10. That we need 1 bay, 1 dedicated bay for this coupler, for this real coupler with 1 circuit breaker and with 1 CD. But we need also 1 additional bay for the sectionalizing disconnector. If you have more sectionalizing disconnectors, you can use the same bay, but you need at least 1 dedicated bay only for the sectionalizers. How many CDs do we need? I think that's quite simple. You simply have to count the number of current transformer symbols on the single line. And that's 10, of course. Exercise 3 may be also quite interesting. First of all, how many buttons do we need? I think this could be answered quite fast. That's, of course, we need 2 buttons. Do we need a disconnector image? Maybe quite interesting because it looks a little bit like a double busbar because we have 1 bus zone, 1 bus section on the top, and below we have a further bus sections. But please look carefully. The feeder, I can't find any CD which could be assigned to different bus zones. So we need no disconnector image. We have no busbar disconnectors. It's no disconnector image because you can't switch CDs by disconnector positions to different bus zones. Numbers of bays. Look carefully. It looks a little bit like, and from customer point of view, it looks like 5 bays. But here we need really 10 bays because we need really 1 bay per pair of CT and circuit breaker in each bay. So we have here, from customer point of view, the 2 bays will be combined to only 1 bay, but for our busbar protection, we need really 10 bays. Number of CDs, okay, that's easy. These are 10 current transformers, 10 measuring points. Last exercise, that's a so-called circuit breaker and a half scheme. Maybe also interesting to look about it. How many bus zones do we need in a circuit breaker in the half scheme? So that's a circuit breaker in a half scheme with so-called 5 diameters. And the number of bus zones, of course, it's only 2. So you have 1 bus zone on the top and you have one bus zone on the bottom. Do we need a disconnector image? So you have to look carefully. So also here, you can't assign any feeder current transformer to different bus zones. You can't assign this feeder current transformer either to the bus zone on the top or to the bus zone on the level. So we don't need a disconnector image. Numbers of bays. So we have 5 diameters, but it will be split into 2 independent bus zones. So we need in total 10 bays. So 5 bays directly assigned to the upper bus bar and the 5 bays assigned to the lower bus bar. And the number of CTs here also quite easy, is also 10. So I hope you were all quite successful answering my short exercises. Now I have completed to explain really the centralized busbar protection and how to find the correct device type of a centralized busbar protection. But what's about a distributed scheme? So we have to answer the same questions. How many bus sections must be considered? These questions is necessary to find the correct type of the 7SS85CU. It's not necessary to find the correct form of the bay unit of the merging unit. Do we need a disconnector image? The same as before. Also necessary only to find the correct bay in the 7SS85C. How many measuring points and bays will be needed? As already said, I have here, it's striked out, the end base is striked out, because in the fully distributed approach, it's not necessary anymore to count the number of bays. So you only have to count the number of measuring points, and of course, the number of measuring points, will be located and must be located in the bay unit. Do we need circuit breaker failure protection? Also this question is necessary in the bay unit. And also the end fault protection must be located in the bay unit. So all in all backup protection functionality must be located in the merging unit, must be located in the bay unit. And of course, the bay units, for the bay units also, it must be answered the questions, how many binary inputs do I need, how many outputs do I need in the bay unit. Okay. Some words about to find the correct merging unit as a bay unit. The dedicated bay unit for the distributed busbar protection in the first step is the 6MU85. And I have, when I remember correctly, more than 50% of the audience already knows quite well the 7SS52 busbar protection system. And here it's maybe to make it easier, if you are used to configure a busbar protection system with a 7SS52, you can make the same the following approach. You are selecting a 6MU85 in the hardware standard variant HA1. And then you are adding 95 additional function points for the connection to the 7SS85CU. And this device configuration is very similar like the small bay unit of the 7SS52, the 7SS525. So it offers here 11 binary inputs. It offers 9 binary outputs, 4 CDs, means 1 current measuring point, and it also brings 1 PD module, which is mandatory for the communication to the 7SS85CU. And as already said, that's the same like the small 7SS52 bay unit, the 7SS525. If you are used more to the big 7SS52 bay units, the 7SS523, then you simply add to this hardware variant HA1, one IO205, and one additional small display. And together, and with this hardware variant, you have, it's the same like the big Bay unit 7SS523. One additional remark to this 95 additional function points you have to buy. With this 95 additional function points, you buy a flexible stream according IEC 61869, and this stream is suitable for up to 32 analog values, which means this is possible for up to 8 CDs. And in contrast to the Bay unit of the 7SS52, where it was possible every time only to cover one CD with the Bay unit of the 7SS52, with the 6MU85, or also with all other modular SIPROTEC 5 devices, you can cover up to 8 CDs, 8 current measuring points within one Bay unit. Of course, you have to think about to add also more I/O modules to cover all these 8 CDs, but in principle, it's possible, and you have to pay only one time this additional 95 function points. And with this additional 95 function points, you can send up to 8 current measuring points to the 7SS85 center unit. As already said, it's possible in the 7SS85 that each modular SIPROTEC 5 device can be used as a Bay unit for the distributed busbar protection. So here in this example, I am using for a 7SJ85. So we have a 7SJ85. And what we need, of course, it's a distributed busbar protection. We need communication. And for this communication, we add this Ethernet BD communication module. And to activate in general the process bus functionality in a modular device, we have to pay 200 function points. And for the special communication to a 7SS85, we have to add further 95 function points. So all in all, to use a 7SJ85, to use a 7SL or a 7SD or 7UD or whatever is available for a Bay unit for distributed busbar protection, you have to add the communication module, and you have to add 295 function points. And also here in this case, that's the same. You can use it for up to 8 current transformers, up to 8 bays for communication. So last but not least, how to configure the 7SS85 IEC 61850 compliant distributed solution, which is using the centralized types of the 7SS85. It's a little bit a mix. So how many bus sections must be considered? This answer, the 7SS85 is the same like the centralized busbar protection. So you have the same types, the same significant features available. So you have to answer how many bus sections must be considered. I have to answer whether is a disconnector image necessary. And it's the centralized busbar protection. So we once again need the base in the central busbar protection. So you have also to count for this approach the number of bays. And also all these questions have to be answered for the central 7SS85. Is the N-fold protection very important? In this case, the N-fold protection has to be equipped in the central unit. It's not possible to make the N-fold protection in the merging unit in this case. The circuit breaker failure protection, do you need a circuit breaker failure protection? Here both approaches are possible. My recommendation is whenever possible to use in this solution the circuit breaker failure protection in the Bay unit, in the merging unit. And This will be also, despite of the hybrid solution, of course, how many measuring points will be needed, how many measuring points are necessary. This question has to be answered for the bay unit. And how many binary inputs, how many binary outputs. This, of course, also as it is a distributed approach, must be answered for the bay units. So I guess I do not know questions and answers, but I guess we will after the part of Nina. So Nina now will take directly the practical part, or not?
No,
Sorry.
because that was a lot of listening in for our participants out there. And let's see if Gerd has some questions for you. And it looks like, because we decided we will a question and answer part do right now. Then again, a short break to give our brains and eyes a bit rest, maybe eventually to get some of the cold air in. And yeah, let's take a few of your questions. Thanks for sending them in. And by the way, if we do not take all of your questions or answer all of your questions, we will send out answers to your questions in a few, maybe not days, but weeks, because we're running into the Christmas season, but you will get answers. So, and now let's see. First question I see here is from FP. It correctly in the distributed Busbar Protection 7SS85, the 50BF, so it's circuit breaker fault protection function, is included in the central unit. Can you scroll?
Please don't jump from one question to the next.
That was a new question coming in. No chance for Gerd there. It's fine. So if the 50BF, so the circuit breaker fault protection function, is included in the central unit, and the end fault protection is included in the bay units, why is that? And the question is it also possible to have the 50BF configured in the bay units? So that was the circuit breaker fault protection.
Okay, I guess I have understood. Okay, so first of all, I guess as you are writing about the distributed busbar protection, your questions is regarding the 7SS85 CU solutions, the fully distributed busbar protection. Okay, so first of all, maybe you have misunderstood or I have explained it not well enough. As a circuit breaker failure protection in the 7SS85 CU solution must be also in the bay units. Maybe explain it a little bit more in detail. So we have in SIPROTEC 5, we have only one circuit breaker failure protection functionality. We have the same circuit breaker failure protection functionality for all SIPROTEC 5 devices. Also means the merging units, the distance protection, also for the non-modular devices, they are the same functionality. And this functionality will run every time in the bay unit. And it's identical until trip T2. So until trip T2, it's also the same functionality. What is available in the 7SS85 CU is that an internal signal after this trip T2 will be passed to the 7SS85 CU, and there, via the disconnector image, the associated busbar will be completely tripped. This functionality is available every time in the 7SS85 CU. But the start of the circuit breaker failure protection must be, it's not why, it must be in the bay unit.
Oh, okay. So thanks for the clarification there. Yeah, never mind. It's I think there are no wrong questions. It's just like you just mentioned, maybe explained a bit misunderstandable. That's why we are here for you and your questions. Okay, let's see. For the device selection, does this fixed 4000 Hertz and 1S2 represent the 50 Hertz system, or is it also valid for a 60 Hertz system?
It is also valid for 60 Hertz systems.
Okay, That was easy. And then for a 7SS85 busbar, is it sufficient, a single point status of the isolator?
Yes, it's sufficient, but you should, as I have tried to explain, it's sufficient, but please use the signal of the normally close contact, which bring you which bring you a high signal in case of an open disconnector. That's very important. Don't use the normally open contact, because this is not safe enough. Because you must imagine you must be on the safe side if you have a loss of the auxiliary voltage. So it's safe in case of you are using the normally closed contact. And in this case, you can use also a single point status of the isolator.
Okay. Yeah, always stay on the safe side and think about what will happen if there's any kind of fault. Exactly. And now let's see. Once again, a lot of abbreviations in it, but I'll try to read it. Why did we not consider the CBFP, so circuit breaker failure protection, on the bus coupler in this double bus basic configuration? I think that was one of your examples.
Yeah, okay, I can answer this. It's also a little bit maybe not too easy, because circuit breaker failure protection will be also explained in detail in our next tutorial. Some words. What we have to consider and where we have to pay function point for circuit breaker failure protection is only an instance to start the circuit breaker failure protection from an external device, from a line protection device, a feeder protection device. Yeah? And such a device you will not have in the coupler. A circuit breaker failure protection, when the busbar protection itself will trip, that's the called inherent circuit breaker failure protection, is available anyway. So you trip one bus zone, and then of course you will start a circuit breaker failure protection in the coupler, which will trip the associated zone in case the circuit breaker and the coupler fails. But therefore you don't have to pay function points, therefore you don't have to pay money. This kind of circuit breaker failure protection is every time available. You only have to pay for the circuit breaker failure protection, which will be started from an external device.
Okay, thanks a lot. And I think we have our producer back again. I hope that everything went out fine. And if not, once again, the repetition, we will send the answers to your questions, just in case you had some problems listening in to us for the last few minutes. Yeah, production is back on site, it looks like. So we continue this round of questions. And VB wants to know, with one BI for DS position, which type of auxiliary contact should be used? Oh, that's NO or NC, so it's normally open or normally closed, right?
Yes. I guess I have already answered
That's
it.
true.
It's clearly it's a normally closed contact.
Yeah.
That's very important. Don't use the normally open contact with only one binary input. It could be very dangerous otherwise.
Thank you. And the next question I see is, what is gray zone protection?
Do you want to answer?
Maybe I take this one. This gray zone, the area between the circuit breaker and the current transformer is meant. And this is typically protected with the end-fault protection. And we will explain this in our next webinar.
Once again.
Wow, you see, you just place questions which will be answers. And that tells me that we are on the correct track with this tutorial. And next one is there implemented an algorithm to check whether the auxiliary contacts of the switching devices, the circuit breaker and the disconnectors, are still in accordance with the primary position of the devices?
Yes, but I have already mentioned this supervision in case of is then only possible with two binary inputs, using both the normally closed and the normally open contact.
Okay, yeah. And if
So this functionality is not available if you're using only one binary input.
that's a long one. Let's see how we will manage to read and scroll. Gerd will manage on that. So NA and the long name. Please tell me whether it is low impedance or high impedance busbar protection operated based on, I think it's voltage drop at relay, circuit setting current, and is it considered as voltage measuring device? Then it operates based on differential current, but both or voltage measuring device with developed across a secondary circuit. It's a bit fragmented, I think. Maybe you nevertheless get it, but and also in ideal or practical case, differential busbar protection operated based on two difference of CT, then what is extreme condition of unbalance between two current transformers, and what is safety margin in voltage setting, respective to voltage of the fault, I think. And well, that's a long and complicated one. So you see, I'll try to read that. We'll see if somebody will be able to answer that. And if not, there will be a direct contact afterwards.
I'm sorry, I'm not absolutely sure. Nina, I guess you know too.
So
maybe this is a little bit related. Sometimes it seems a little bit related to a question whether it's possible to add additional to the busbar differential protection also as a second criteria an undervoltage functionality or in voltage drop. This, of course, could be combined easily to make an undervoltage functionality and to release the trip of the busbar differential protection with this drop of the voltage. This can be done via small CFC and via undervoltage or voltage drop functionality in the merging unit. But it was not completely related to these questions because it was with some CTs, but sorry, at the moment I'm not able to answer. I didn't understand it completely, I guess.
No problem. I think we'll take it offline and then go into a one-on-one discussion. Sometimes that helps. And PT had asked, can you clarify the concept of the disconnector image and where it is utilized? I think it was part of some of your examples, right?
Okay, there are two parts of disconnector image. One is the disconnector image really from the marketing point of the price point of view, whether you need a disconnector image or not, but nevertheless, we have a disconnector image every time available, and how to see also the details and of the concept of the disconnector image. Once again, tutorial in January.
Oh, perfect.
I think it will be the part of Nina when I remember correctly.
Yes, nice outlook on that. Huh? Right. So we take the next question from HM, and HM wants to know which CTs are used for busbar zoning, and can line CTs be used for busbar protection, or is it only busbar CTs?
Busbar zoning. Sorry, it's not clear for me what exactly means a line CT and what means busbar zoning. No, sorry, I am not clear with this question. You know, any idea?
Maybe just that we can add that the requirements for line CTs are typically even higher, for example, for distance protection.
Do you mean line CTs means CT for line protection?
Maybe.
I guess.
Okay, idea.
And here the requirements are typically higher as for busbar protection. So if I understood this correctly, yes, it would be possible to use the line CTs for busbar protection. But I'm also not sure if this is the right interpretation.
Maybe one of the other
Oh, no, this will be interesting. Now,
Thanks for sending that in. There's somebody who knew Matthias Schick, and now that's an applause to you, Rainer, answering a lot of questions to the new system in a good, proper, and professional way. Thank you for that. We take that in, and no question to us. So I thank you there.
Thank you very much for the flowers.
And now I need to admit, I have no clue about our timing issues. Can we continue the questions round? So we take about, let's say 2.5 minutes more, or 2 questions, and then give our brains and eyes a bit more rest. So let's see the question from coming in here. Is it possible to configure 2 voltage levels? So 400, for example, 400 kilovolts and 132 kilovolts in the single 7SS85 central unit, and so that the single central unit will protect both 400 kV and 132 kV bus bars at the same time?
No, this is not possible. Here you need 2 individual busbar protection systems.
In general, yes, of course. You need a transformer from the 400 kV to the 132 kVs. And the transformer, typically, we are no transformer protection, it's not possible. Maybe one single exception where it may be possible if you have really completely independent CTs, both for the 400 kV and the 132 kVs. Yes, independent CTs and completely independent bus zones. So it's not allowed to have inside really the current transformers. That's not possible. But if it's completely independent, you have completely independent CTs without the current without the transformers, then it may be possible. But we have to enable the check zone. So in general, I would agree to Nina. No.
Better not. You could,
Better no.
but we do not recommend that.
No, it will be possible with exceptions and anything, but in general, to be on the safe side, please don't do it.
I mean, and we learned that we will protect expensive equipment there. So maybe, I mean, I would refer to something like my bike. If I pay a lot for the bicycle, so that's your assets, and then I just buy a T-block, well, that will not protect it. So maybe that's something similar around there. And then we take one last question before our next short break. So can the 7SS85 work with MUs from other manufacturers?
Yes, they have done in the meantime some interoperability checks where really the 7SS85 has been used as a busbar protection with third-party matching unit, and it worked.
Perfect. So we already tested busbar protection with other vendors. Thank you so far. So
in the last 30 minutes of this tutorial, I want to give you a short demonstration of our SIPROTEC 5 configurator. I want to just remind you shortly on the example Rainer demonstrated earlier. He explained an example of a double busbar system with 4 feeder bays and 1 coupler bay, so 5 bays in total. For this setup, the disconnector image was needed. And I want to show you how to select the devices for this setup for a centralized busbar protection, for an IEC 61850 compliance solution in a fully distributed setup, and for the 7SS85 CU solution. Okay, here I have already opened the SIPROTEC 5 configurator. I go to full screen now. Let's zoom in a little bit. So I hope it is good to read and see for all of you. This is the starting page of the SIPROTEC 5 configurator. So here you have the entry options, device, or of course devices. With parts, you can order spare parts. 65 is the possibility to order our software, and function extensions is maybe also interesting for the busbar protection, because with this option in the configurator, you can offer a DAF file to change the significant feature later on, if your, for example, system has changed or extended. Okay, in our case, I want to start with device. And I go here with the busbar protection. But of course, all our other SIPROTEC 5 devices can be selected here as well. Here's a short description of the busbar protection, but I think we heard enough of that today. So just go to next. And this is the point where you choose the significant properties of your device. So the first 6 here are the significant features for the centralized 7SS85 and for the IEC 61850 compliance solution. The 5 solutions here on the bottom of the list are the significant features relevant for the 7SS85 CU solution. That's why here this mentioned with CU double point. Okay, as I said, I want to start with centralized 7SS85 setup. And yeah, we said we have 5 bays, 2 zones, and we need to disconnect the image. So here, the third option is the right one for us. Here you can choose if you, for example, want redundant power supply, but in our example, I just leave it like that and confirm it with next. Here you can choose the standard variant with which you want to start your configuration. So there are 3 options that are offered here. The first 2 are interesting for the centralized configuration and the IEC 61850 compliance solution. The standard variant V4 is interesting for the distributed busbar protection, because as you see here in this overview, you already see how many binary inputs and outputs are available, and how many current inputs are available. And for the last variant here, the speciality is that there are no current inputs, but an Ethernet BD module for communication. And that's why the standard variant V4 is the interesting one for the distributed setup. But in our centralized configuration, I go with standard variant V1 as an example. Confirm the step. And here on the top of the website is always an overview. How does your device looks like at the moment? How many binary inputs and outputs are available? How many current transformers and voltage transformers? So whenever you change something down here, you can always check in this overview on the top if already enough of inputs and outputs and current transformers. So this is a nice overview. Here you can see our device already have 1 base module and 1 additional extension module, IO201. So with this standard variant 1, there are already 3 current input terminals available. And here is also a very important hint on the slide that for busbar protection, only terminals with current 4x protections are allowed. So please make sure that you select the right option here. Okay, but yeah, in this case, we have 12 current inputs. This is not sufficient for our example. As we said, we had 5 current measuring points, 5 base in this case. So this means we need up to 20 current inputs, 5 times 4 in this case. So I need more of these IO201 expansion modules. This is possible to add at this step here Here's an overview of all the possible extension modules that are available. One IO 200 round is already selected, and I increase now the number up to 3 for our configuration. Now we can double check if this is enough. And now we see for the current transformers, we have 20 now, and this is sufficient for the configuration we want to do now. Okay, so get to the next step here. And this is where you have the possibility to select the plugin modules for communication. At the moment, no module is available here. You can, for example, add additional module, like if, for example, an Ethernet BB module for your substation communication. In our case, I just leave it like that and jump to the next step. Here, once again, nice overview. What do we have selected in our basket already? What modules are there? What expansion modules are added? And at this page, you can choose, for example, if you want a small display or a big display. We always recommend like a large display for the busbar protection, because then you have the chance to really show parts of the single line on your HMI display. Here you also have the option to increase the number of LEDs. At the moment, the pre-default setting is 16, but it is possible to increase this number up to 64. I will do that real quick. And then you can see now all these expansion modules have LEDs as well now. So this is really flexible here to increase the numbers. Here are also some other things you can change, like do you want a key switch, for example, or not? But this is not so relevant for this tutorial right now. In the sales options, maybe it's worth to mention that you can here change the warranty, and you can change the firmware with which the device is then delivered from the factory. And now last, very important, is the function points calculator. Open this and we will have a quick look. So the first overview is the functions that are already included, where you don't need additional functions points for. So, for example, this is of course the busbar differential protection itself, because this is the main protection function, and this is of course included. You have also the inherent circuit breaker failure protection, which Rainer mentioned earlier. This is also always included in this setup. Okay, and now we jump to the function with costs. And here you have really the option, you really make yourself clear about what functionality do I want to put in the device. Do I need, for example, a backup overcome protection, for example, then you can increase the number here. In our case, I'm of course interested in the circuit breaker failure protection 3-pole in this case. And we take this in our case 4 times for all of the 4 feeder bays. Increase the number to up to 60 points. And down there you always see an overview of how many function points are needed in overall. Okay. Then I also add the endfall protection, which is also always recommended for the busbar protection. This number increased for up to 5, because this is also interesting for the coupler bay. Okay, and then also important, we have to increase the number of the function points for an additional bay, because in the significant feature we choose, only 4 bays were included, and we have 5 bays in the setup. So I increase the number from 4 to 5 here. Okay, let me check my notes. I think this should be all for our centralized busbar protection. So we need the 150 additional points. At least actually we need 135, but the next higher function point class would then be 150. I apply these function points to the configured device. And then on the top of the site, you can copy the shortcode, the long code, check the list price, and download the selected device overview. So first device finished. Okay, so here we are, start again. And here down, you see a list of the devices you already selected. But we start all over again with device. In this step now, I want to configure the device for IEC 61850 compliant solution in a fully distributed setup. So I start once again with the 7SS85, and in the second step, I will select the corresponding merging units for the setup. So I go with Busbar Protection again, jump over this description, and in this case, we need exactly the same significant feature as before, because the first 6 are interesting for both for the centralized setup and for the IEC 61850 compliant solution. I go with 2 zones for base and the disconnector image. Confirm the step. And yeah, as I explained a little bit before, here the standard variant V4 is interesting. This is always interesting for the fully distributed setup, because here all the process signals from the base are connected to merging units, and the merging units are then connected to the 7SS85. So we don't need current inputs in the 7SS85 itself. So I select this one and confirm this step. Once again, this overview of binary inputs and outputs, and as you see, 0 current transformer inputs in this case. Oh. Okay, no, I accidentally pressed the wrong button. Yes, let's jump back. And okay, here we are. Close this website, go back to full screen. Okay, sorry, press the hardware manual button. So this is an option to always have a look at the hardware manual. Okay, so here, of course, you have the option also to add and remove some expansion modules. But in this case, this base module is sufficient for our setup. So I could scroll down, go to next. And here you see an overview of the plug-in modules for communication. As you see in the standard variant, I choose already 1 Ethernet BD module is available. And 1 Ethernet BD module is, of course, sufficient for our 5 base. So as we explained earlier, with 1 BD module, you can cover up to 15 measuring points at the moment for the 7SS85 CU solution. And with version 9.40, it would be all up to 16. So in this case, with our 5 base, we are totally fine with 1 BD module. So I confirm this step and go to the next. Here, once again, I changed the display type to a large one. And we will have another look at the function points calculator. Here, for the function free of charge, it is interesting to mention that here, the process bus client function is already included in the setup. So you don't need to pay function points for the communication in this case, in the 7SS85. And the IEEE 1588 PTP Grandmaster Clock functionality is also free of charge in the 7SS85. This can be used for synchronizing the sample measures values. And if you activate the Grandmaster Clock in the 7SS85, no additional switches, for example, with a Grandmaster Clock included, or no additional Grandmaster Clock would be then necessary. And it doesn't even cost some function points here. Okay, so, and of course here the busbar differential and the inherent circuit breaker failure protection are also included, same as before. So I go to the function with costs now. And here, maybe I start this time with the bay, because we also need here 5 bays, not 4. And now, as we explained earlier, the end-fall protection is a functionality we must implement in the 7SS85 itself. So here, these 5 points, 5 times 5 points, are necessary for the 7SS85. Things like the circuit breaker failure protection or even additional backup protection functions can be implemented in the merging units, and this is what we recommend. So I just leave it like that with the 25 points for the end-fall protection and the 50 points for the additional bay. So apply this, and we already then configured our second device for the IEC 61850 compliant solution. Okay, so for the distributed solution, we of course need merging units as well. And this is what I want to do right now. The merging units for our IEC 61850 compliant distributed busbar protection. So this time I select merging units here. Jump over the description. And here are also some hardware variants offered. Of course, they differ with the number of binary inputs and outputs and voltage transformers in this time. I go with the standard variant AJ1, and this is comparable to the 7SS525. So go to this. Here you see already one current input is included. If you have, for example, a coupler with 2 CTs, or for example, you want to put more than one bay in one merging unit, then of course you can add an additional extension module and increase the number of current inputs here. Okay, but in our case, we have one merging unit for each bay. So I jump over this step and go to the communication modules. Here also one Ethernet BD module is already included. This is fine for us, and I go to the next step. Okay, here once again the overview of our merging unit. Here maybe it's worth to mention that of course you can add a display as well to the merging units, a small one or a large one. In this case, maybe I go with a small one. And then it is possible to add some measuring signals or whatever you want, disconnector status, for example, already in the merging units HMI. Okay, so, but here, of course, the function point calculator would be, again, interesting. Okay. Here it is not so much to show in the free of charge section. We jump directly to the function with costs. And here I want to start right with the first point. As you can read, the IEC 61850-9-2 merging unit functionality is already included one time in the 6MU85. So here we also don't need to pay function points for the communication with the central unit. Maybe also here worth to mention the IEEE 1588 Grandmaster clock can be activated as well in the merging unit, but in this case, in the merging unit, it costs 200 function points. And yeah, we actually recommend to activate this functionality in the central unit and not in the merging unit, but it would be possible. Okay, so here, of course, you can select function points for the backup functionality. And in my case, I want to keep my focus on the circuit breaker failure protection. Here I add 5 points for the circuit breaker failure protection. And for those who really watch carefully, you may have recognized that the circuit breaker failure protection only costs 5 points in the merging unit. So it is not only interesting to keep the processor load on a lower level, it is also interesting from a financial point of view because the function points are less in the merging unit than in the central unit. Okay, so this would be all we need for the merging unit. So we only need here 5 points. So I apply this configuration and we are finished with our merging unit. So 2 more devices to select. We go now with the 7SS85CU solution. And there we, of course, need, once again, the central unit and the merging unit. I will go a little bit faster, but yeah, I will try to mention all the worthy parts that are different than before. So let's start with device. Start with the central unit. And now these significant features at the bottom here, the CU double point, are the important ones for the 7SS85CU solution. Here, maybe I can explain again that maybe if you recognize that there are no base mentioned here, that's because these up to 48 base are available in all these variants, independently of the significant feature you select here in this step. And yeah, in our case, we are interested still in the disconnector image. So I go here with the 6 zone, including the disconnector image. Confirm this step. And here only the standard variant V4 is offered because this is the only interesting one for the 7SS85CU solution. Okay, no additional modules are needed, extension modules are needed. And here, once again, the BD module is already included. If you really want a device with these up to 48 measuring points, the slots in the base module would then not be enough because then you need 3 Ethernet BD modules and only 2 slots are available. In this case, you need to add an additional expansion module CB202. And then you have 3 more slots available to add Ethernet BD modules. In our case, this one would be sufficient. And of course, if you want substation communication, you can add another Ethernet BB module, for example, as well. But I go with no module, only our Ethernet BD module. I confirm this step and jump directly to the function points calculator. And once again, here, the process bus client protocol for the 7SS85CU, this is the 3rd point here, is already included. And of course, the Grandmaster clock functionality is also already included in this version. Of course, the basic functionalities are as well included. So in the function with costs, there are, of course, some options you can add. Something like, for example, the bus coupler differential protection if you have two CTs in the coupler. But in our case, I will just go with the 0 points. This should be sufficient for our small example. So apply this. And yeah, with finish, we have finished our configuration for the central unit of our 7SS85CU solution. So one more device to select, the merging unit for our 7SS85CU solution. So I go with merging unit this time. Jump over the steps and select in this time, once again, the variant AJ1. And here almost everything is the same as before. We already have one current input. This is sufficient for our configuration. We don't need further expansion modules, only if we, for example, have more than one CT in one bay. I confirm this step. We already have one Ethernet PD module, which is also sufficient for our configuration. So I go to the next step. And here I scroll once again directly to the function points calculator. Okay, and here I want to show you the function with costs for the merging unit device. And here it is the third point I want to show to you, because here the IEC61850-9-2 merging unit function for the 7SS85CU solution costs 95 function points. And these 95 function points are mandatory if you want to use the merging unit in this setup. So this number needs to be increased to 1. And once again, you can add additional protection functions. In my case, I only want to add the circuit breaker failure protections repo, 5 points. And I want to add the function points for the end fault protection. And here, maybe to the difference than for the solutions before, only for the 7SS85CU solution, the end fault protection is activated in the merging unit, and that's why I have to pay the function points here for the merging unit. Then I have overall required function points from 105, which means I need a device with function point class 125. So apply this and finish my configuration. Okay, and here we have the overview of all the devices selected, and this was all I want to demonstrate to you in the SIPROTEC 5 configurator. So, Michaela, Rainer, another Q&A session.
I think so. Thanks, Nina. Just in time. We have time for about 10 to almost 15 minutes more questions, and let's see if there are some. And yes, there are. Once again, I think the first question I see here is one you already answered, because is there an option to order the merging unit with a display? And yes, you were able to select that. Probably you sent in the question before we were at that point of the presentation. Thanks for that. So let's see the next question. What protection redundancy does Siemens recommend between merging unit and 7SS85? For example, the merging unit would carry out line differential and phase OC and EF, End fault is EF. What's OC? I mean, you probably know.
Overcurrent and end fault.
An end fault. But in the event this device fails, what protection redundancy can the 7SS85 provide? To get.
Will you answer?
Okay, with fully distributed busbar protection, the 7SS85CU, we have no redundancy. Means it's not possible to have overcurrent protection or end fault protection in the 7SS85 device. So if you need here, how to say, the main protection is 7SS85 busbar differential protection, and the backup, the end fault protection and the circuit breaker failure protection is anyway a backup protection functionality. So if you need here also redundancy, you have no other possibilities than to have redundant merging units or redundant bay units, or you have a separate line differential protection device, and then you can add there a redundancy of the overcurrent protection or the line differential protection. So it has no redundancy possible for a line differential protection in the 7SS85 and the merging unit or the bay unit.
Let's say I'll take the one from HH questioning about the merging unit. Can the small display show circuit breakers and disconnectors, or do we need the large display for that?
It is possible with the small display, but of course, if you want to really put a little bit of the single line diagram on the display, then it makes sense to go with a large display. But if you want to just display the status of the disconnectors and the circuit breaker itself, it is of course also necessary with a small display.
Okay, thank you. And then there's a question, sorry, but I cannot understand why like the same 50 BF function, so the 5 function points per instance, is required or instantiated within both Busbar Protection CU and the MU. Was that the... I think Nina got it. Yeah, you configured that. That's
the question. Yes, I think I understand it. I think it is meant that the function, the circuit breaker failure protection in the 7SS85 costs 15 function points. In the merging unit, it only costs 5 function points. And I would say explain it like some historical, political.
Yeah, but I think it was not the questions. I guess he understood that you have a circuit breaker failure protection both in busbar protection and merging unit. He did not ask about different prices.
Yeah.
Okay, then go with
I
question.
guess, but maybe this was a misunderstood, because Nina has explained more or less 3 systems: the centralized, the IC compliant, and the fully distributed 7SS85CU. And you will have either the circuit breaker failure protection in the central unit or in the bay unit, but she has not demonstrated that the circuit breaker failure protection is both in the central unit and in the bay unit. Maybe it was mixed up because she has shown us 3 systems. In the centralized, of course, the circuit breaker failure protection was in the central unit, also in the also in the IC compliant, you showed in the merging unit, whereas in the other 2 systems, in the distributed and in the IC compliant distributed function, it was only in the bay unit, not in the 7SS85 central unit.
Missed one step, maybe, like I did. I wasn't sure how often we had this. So for the 3 different systems, we would have this circuit breaker protection 3 times, because we have 3 different configurations. Once it's in the central one, and on the other 2 configurations, it's in the merging unit, right?
Exactly.
Okay, so I think now I got it, and I hope you too. And if not, rewind and watch it again, or ask us again. So for the case, the relay shall be equipped with VT modules to measure the bus voltages, so that reference load flow can be taken from bus voltage, as well as for providing secure operation in case of inadvertent shorting of CT. Do you see a question out of that?
No,
I don't
no,
get the question of it.
I may, I may, how to say, maybe I know what could be the question. So voltage, you can, in the 7SS52, it was not possible to measure any voltage. So if you need an additional under voltage criteria for tripping, you have needed a separate device and bring the result of the under voltage via binary input and release a busbar protection tripping. In the sensorless busbar protection, it's a normal modular device. You can already bring voltage measurement, voltage terminals inside the device, and you can make this additional voltage criteria in the same device. If you have a 7SS85CU system, the 7SS85CU system can't measure any analog values. It can't measure in the sender unit the current, and it also cannot measure voltages. So if you need a voltage for a voltage criteria or just to display it, so you have to do this in one of your bay units, in one of the merging units. And if you want to have an overvoltage release, you just send the result of your undervoltage criteria via an additional goose message to the sender unit, and there you make the undervoltage release. Maybe this was a question, and I have answered to this question. If not, we can have a contact later when we will answer this question.
So the next question already refers a bit to that. So some customers ask if VT modules can be added to the 7SS. Is it possible? And if I listen to you correctly, it's depending on the configuration, right?
Yeah.
Okay.
So
I already answered. No, we will not do a rewind here. So let's see how to implement and configure the circuit breaker failure protection into the 7SS85CU. I think you've activated that. If the question is how to really configure that somewhere else, that would be another tutorial, I think, right?
Yes, and I think we will show this in our last tutorial where we explain how to configure the 7SS85CU.
So stay tuned.
But the circuit breaker failure protection itself until trip T2 will be every time not in the 7SS85CU, it will be in the merging unit. But as I have already tried to explain, after the trip D2, the circuit breaker failure protection to trip the associated zone, this functionality will be every time available in the 7SS85CU. But there's nothing to configure, it's just available.
Okay, thank you. And I think we'll take one last question there from CP. And as far as CP understood from other webinars, from the version 9.3 upwards, there are no standard steps for the FP, so that's function point of failure protection. Is this possibility available only for the DAV extension files?
I guess FP means function
In
points.
this point, function points, yeah, all these abbreviations. Let's see.
This possibility, I guess there are no standard steps for the function points. I guess he means his classless functions together with the function point manager. But what means this is only available for the DAV extension? It's available, yes, for all SIPROTEC 5 devices. What means? So I'm not completely clear with this question.
Okay.
I guess it's something related to classless function and function point managers. And this classless functions, of course, will be also possible for the 7SS85 because it's available for each.
So if that answers your questions, you're fine. If not, contact us again. And that brings me back to thank you for an active participation here in this webinar, in this first of its kind tutorial. You've already heard that there will be 3 more. It's a series of 4 tutorials we currently have planned for you. You took vividly part in this questions field. And nobody asked the question that I used to answer. Yes, you will get access to the recording. We will send out the recording. We will send out, and it will, because of Christmas break, it might take a while until we send out all the not only the questions, but the answers from the experts. So thanks a lot for handing those in. Maybe you already remember some of the benefits of the tutorial, and we hope that you deepened your knowledge on busbar protection and that you learned how to correctly select the correct relay. And so I hope that you will join us on the next webinar on the 24th of January next year, so in 23. And there you will learn more about busbar protection functions, algorithms, and settings. So less selection, more settings and hands-on I found on my list here. So thank you, Nina. Thank you, Rainer, for being here with us in the studio. Thank you out there for joining in. Have a nice festive season. Have a nice kind of transition into the new year. Stay safe and sound, keep your systems protected, and see you in the next tutorial. Bye.
So, goodbye.